Hey, what's up, guys? It's Bob from Code Bros, and we're on to top interview questions, medium set, linked list. Question number 2, odd even linked list. So, given the head of a single linked list, group all the nodes with odd indices, followed by the nodes with even indices, and then return the reordered list. So, the first node is considered odd, the second node is even, and so on. Note that the relative order inside both the even and odd groups should remain the same as the given input. Okay, so basically over here, we want to get all the odd nodes together and in the same order. So 1, 3, and 5. And it's not the value that's odd, it's the placement. So 1 is at indices 1, which is odd. Then 2 is at indices 2, which is even. The actual value doesn't matter. They just did that to make it a little bit easier to understand. So over here, they grouped 1, 3, and 5. And then they grouped 2 and 4. And they connected 5 to 2. And they returned the whole linked list. Same thing over here. They connected 2 to 3 to 6 to 7. And they connected 1, 5, and 4, and they connected 7 to the start of the other linked list, which is 1, 5, and 4. So this is a nice, easy example. Let's actually figure out how to do this question a little bit more in depth. So, 1 second. All right. So that's the array that we have. First thing first, we need an odd linked list and an even linked list to store the odd values that we have and the even values that we have, because we're basically splitting this linked list into an odd and even linked list. So let's think of edge cases. If usually the linked list for odd would equal to a head, which is the first value, right? That's the first odd value, and the linked list for even will equal to head.next. So we don't want to have any null pointer exceptions when we do head.next. So if the head is equal to null, and the head is the head of the list linked list that we're given. So if head is equal to null, or head.next is equal to null, head.next, it means that there's only one value. That value is odd, so you can just return it. Or head.next is equal to null. Is all double equal to null. We can just return the head, right? Because these are cases of 0 values, 1 value, and 2 values. And in all 3 of these cases, we don't have to do any reordering. Okay, so these 2 won't cause any issues now. So let's look at the value of odd and even. So odd is initially 1 and even is initially 2. Okay, so we want the next value of odd to be equal to 3, right? And we know that this is still a linked list. This is equal to head.next. We could get odd.next is equal to 3, right? And what is 3? 3 is even.next. So we could do odd is equal to even.next. And I like this problem because it's like pretty simple once you figure it out. And it's a nice clean solution. So odd.next is equal to even.next. So the next value for the odd linked list is the next value in the even linked list, because after even is odd. Like all numbers are odd, even, right? And then you can update the odd. So odd is equal to odd.next. And then we can do the same thing for even. So the next value for even would be the value 4. So how do we update it to 4? We can say even.next equal to odd.next. And then we can update even. So even is equal to even.next. And just like that, you're basically taking one value and using the value that it normally points to and using that as the next value for the odd or even list. So the odd.next, we set that equal to even.next. And we just go through like this until we're done going through the array. And there's 2 cases for this. So we continue like this when even is not equal to null. So let's put this in a while loop. While even is equal to null, because even.next would cause an exception, right? And we want even.next not equal to null. So the reason we want even.next not equal to null is so that we don't want the odd value to equal to null, right? Because we want to connect the tail of the odd linked list to the head of the even linked list. So with that, if we set even.next not equal to null, then we'll never have the case where we have this equal to point to a null value. So if we just finish this this example, we have 1 points to 2 points to 4, this points to 5, and we're basically done. And we have our odd and even linked list. So now it's step 2. After we split them, we want to connect the tail of the even linked list, of the odd linked list, because that's the one we want to connect to. Because we want the return array is, let me just copy it here, 1, 3, 5, 2, 4. So it's odd followed by even. So we want to connect the tail of odd to head of even. So we're already at the tail of odd after this loop, because odd is an iterator, right? Odd and even are both iterators. So how would we store the head of the even linked list? we scroll down a little, we can have a linked list even start equal to even. So then when even's going through and updating all its values, this pointer will point to the first value. So that's great. We can just do odd.next is equal to even start. And then we return the head of the odd linked list. And this will give the array that we want, and we just want to return the head, which would point to 1, points to 3, 5 to 4, just like linked lists do. And now let's look at the time complexity for this problem. So time complexity would have to be O(n) because we're iterating through a linked list of n elements. So n is equal to the number of elements in linked list. And what's the space complexity? Space complexity is we're taking these n elements and splitting them into two arrays. So it's just O(n) as well. Because the sum of the two, not arrays, linked list is n elements. So now that we have a rough idea on how to do the question, let's actually code it up. So the first case that we have, I'll just copy it straight from my notes. Double equal to. And the next thing we want to do is create pointers for list node odd, even, and start. So odd is equal to head. List node even is equal to head.next, and list node even start, which is the head of the even linked list, is equal to even. Then we want to do a while loop, just as we've shown before. While even is not equal to null, and even.next is not equal to null. Because if either of these cases are true, we want to break out and connect the tail of the odd to head of the even. We want to set odd.next is equal to even.next. Odd is equal to, so update odd. And do the exact same thing for even. So even is equal to even.odd.next. Because if you think about it conceptually, it makes perfect sense. Because the next value after an odd value would be even, and the next value after an even value would be odd. And update even. And now we want to set the tail of odd linked list to the head of the even linked list. Capital L's. And the way we do that is we do even.next is equal, no, odd.next, my bad. We want to set the tail of the odd is equal to even start. And in the end, we just want to return the head of the even linked list, which is just, no, ahead of the odd linked list, which now stores everything, which is just the head. Return head. All right, so that's just good. Compilation error. Okay, so I forgot a semicolon here. See if I forgot anything else. Nope, semicolons look good. Oh, forgot double equals here. Okay. Fine, that should be good now. Hopefully, let's hope. All right, finished. Found cycle and list node. Oh, odd.next even is equal to even.next. Oh, we do have to do even.next is equal to odd.next. That's what's causing the cycle. And all right, finally, now we got the right answer. Let's submit it for a more comprehensive test and see how we do. So, all right, that's accepted. So, thanks so much for watching. You can always leave comments and suggestions on what questions I should do, what I can do to improve these videos in the comments. They're much appreciated. As always, like, smash that subscribe button. And if you're hiring interns, I'm an intern. I might be free in a later term, so feel free to contact me, and I'll see you guys in a later video.